So go ahead and pause this lecture and see if you can write out the complete ionic and the net ionic equation for these two aqueous reactions. Okay, so let's look at our first example. Let's start out with our complete ionic equation. And what we want to do is get our strong electrolytes and write them as they exist in their actual dissolved state, which as it is in the ionic form. So we have 2 potassium ions, so that's 2 potassium AQ plus 1 sulfate. Here's another dissolved ionic compound, so this is a strong electrolyte. So we have 1 barium and 2 nitrates. Now on this side, this is a solid. Our barium sulfate is a solid. It's slightly soluble, which means for our purposes it's insoluble, so it stays together. But then our potassiums and our nitrates are dissociated. So this is our complete ionic equation, and I ran out of room, so I had to put my 2 nitrates down here. So all we did was take our strong electrolytes and dissociate them out into the ions that make them up. Let me go back here and, for completeness, put the AQ. That is important. Now that we have the complete ionic equation, now it's easy to get the net ionic. What we do is we look for ions that are on both sides, the spectator ions, and cancel them out. I have potassium on my reactant side and potassium on my product side. So those get canceled out. I have nitrate on my product side and I have nitrate on my reactant side. And when I say that they are the dissociated ions. Now I also have barium and sulfate on my left and barium sulfate on my right, which is the product side, but they're in different forms. Here they're aqueous and here they're solid. So they're not exactly the same. So my net ionic equation is going to look like this. This is the chemistry that occurs. Now let's look at our second example. And what we want to do to get our complete ionic equation is identify our strong electrolytes. This is an ionic dissolved compound, so it's a strong electrolyte. This is a strong acid, so this is a strong electrolyte. And this is a dissolved ionic compound, so this is an electrolyte. CO2 gas is not an electrolyte. Anything in the solid gas liquid state is not going to be an electrolyte. And this is water as a liquid. This is a pure substance. It's not going to exist as a dissociated ion. Okay, so my sodium carbonate breaks apart into 2 sodiums and 1 carbonate. Then my hydrochloric acid breaks apart into 2 H pluses and 2 chlorides. And then on my product side, my sodium chloride breaks apart into 2 sodiums and 2 chlorides. And then my carbon dioxide and my water do not dissociate. Oop, that's a liquid. It's hard to see there. Let me just put it down here. That's a liquid. Okay, so now we cross off anything that is on both sides. That's the same. We have 2 sodiums that are AQ. They're completely dissolved, so we eliminate those. We have 2 chlorides that are completely dissolved, so we eliminate them. Those are spectators. Everything else is different. So our net ionic equation is going to be 2 H pluses, and it doesn't matter the order that you write these in. But here is our net ionic equation. Here's the chemistry that occurs. So if you got these right, you are doing great.